Hi guys! Today we are going to look at how to classify all of the chemical reactions that you've been practicing your writing with. Now, as you go through the note-taking guide, you're going to see that there are four main types, plus there are a couple of special types that I'm going to show you about. We're going to go through each type, I'll give you some examples, and then I've given you an example in your note-taking guide to practice by yourself. Alright, so let's start with the first one. It is synthesis. A synthesis reaction is when two elements or two compounds combine to make one single product. Now you see the generic reaction here, and the key to identifying synthesis is just knowing that you're building something. You're making a larger, more complicated product. So you're combining two or more reactants into one larger product. If you take a look at the two examples here on the screen, the carbon plus oxygen are two elements. They combine to give you one product, carbon dioxide. The second example is calcium oxide plus water. Two compounds combine to give you one product. The second type of reaction is decomposition. Now decomposition is really just the opposite of synthesis. So decomposition might make you think of decompose. Decomposing is when a substance breaks down into smaller, more simple substances. So the generic equation, you have some compound that's falling apart into two or more products. The key to recognizing decomposition is that you do just have one reactant. If you look at the two specific examples here, the lead hydroxide breaks down into the two compounds, lead oxide and water, and then the silver oxide in the second example decomposes to give you two elements, silver and oxygen. So decomposition is the breaking down of a compound. The third type of reaction is single replacement or single displacement. In this reaction, you have an element plus a compound, and two of the elements switch places. The generic reaction shows you this, but I think the examples do a better job. In the first example, you have aluminum, which is a positive ion. It's going to switch places with the copper, which is also a positive ion. So because they're similar, that's the two parts that switch places. And then you can see the products that form on the right side. You have an element and a compound in these reactions. Now in the second example, you have chlorine plus KBr. Chlorine is a negative ion, and Br is the negative part of the compound. So those are the two elements that switch places here. So that's the examples for single replacement. The fourth type of reaction is a double replacement or a double displacement. These are going to be the most complicated reactions of the four types. And I say complicated, they're really not, they're just the longest ones, I suppose. You have two compounds as reactants and two different compounds as products. So what happens is the two parts of the compounds are going to switch places. It's kind of like a square dance. You have AB plus CD, and so then the A and the D end up together, and the B and the C end up together if you look at the generic equation. I know that's a little bit confusing, but take a look at the bottom. You've got silver nitrate plus sodium chloride. The positive silver is going to need to switch places with the sodium. So you end up with silver chloride as one product, and you end up with sodium nitrate as the other product. The thing that's going to force a double replacement reaction to occur is the formation of a solid or a precipitant. In the case of this example, it's the silver chloride. Or you're going to form water. Those are the driving forces for a double replacement to occur. So those are the four main types. Now I want to show you some special reactions. The first one is an acid-base reaction. An acid and a base will neutralize one another, and the products that they form are a salt and water. Now salt's not just the compound that sits on your kitchen table. A salt is defined as a compound that's formed when an acid and a base react, but it's not necessarily sodium chloride every time. So just make sure you understand that. Really, an acid-base reaction is just a double replacement. You have two compounds as reactants, and they switch around their parts. You end up with two compounds as the products. Now the trick for you is going to be able to recognize the acid and the base. An acid is a compound that begins with a hydrogen. A base is a compound that ends in a hydroxide ion. It's that polyatomic ion that we've learned earlier. And then when they react with one another, they do neutralize, and so you get the salt and water as your products. But remember, it's just a double replacement. The second special reaction that I want to show you is a combustion reaction. Now, combustion refers to burning. So when combustion reactions occur, oxygen is one of the reactants. A lot of times combustion reactions involve a hydrocarbon, which is a compound that's made of hydrogen and carbon. When a hydrocarbon burns, the products are always carbon dioxide and water. If you look at this example, C3H8 is the gas propane. So when propane reacts with oxygen, or it burns, the products are water and carbon dioxide. And it's the same, those are the same products for all hydrocarbons. But combustion is when a substance reacts with oxygen to produce heat and light energy, and often it can be a hydrocarbon. Now here are some practice problems. What I want you to do is to look at the notes that we've got so far for the 5 different types. I want you to see if you can predict which type of reaction each one of these is. The clue that I will give you is look at the reactants that are given and decide if they're elements or compounds and what types of reactions might be possible for those kinds of substances. So pause the video and make your guesses, discuss it with a partner if you can, and then hit play again when you're ready. Here are the answers. You can check yourself. The hydrogen and the oxygen are 2 elements, so really the only choice for them is to combine. This is a synthesis reaction, and your product is water. In the second one, you have 2 compounds. Remember that the starting material or the reactants for double replacement is 2 compounds. So that's what this one's going to be. The third one is decomposition. You have 1 reactant. That's the red flag to make you notice that this is going to come apart. Copper chloride is going to make copper and chlorine. Not too bad. And then finally you have zinc plus H2SO4. Zinc is an element and H2SO4 is a compound. So this is going to be a single replacement. The zinc is positive and the hydrogen's positive, so they're going to switch places. That's how you get your products. We're going to practice a lot of these in class. So don't worry if you're still a little bit confused on figuring out the products. Just make sure you can classify them. Now, finally, what everybody wants to know is how much of this am I going to have to memorize? The really great thing about your reference tables is that on one of the pages, all 5 of these reactions are listed for you. They give you some generic equations and they give you the products and some ways to identify each type. So go now and get your reference tables and take a look at those examples that you're given and make sure that you understand how to read all of them. So if you have any questions, you can ask me when I see you in class next time. Thanks.